Let's discuss question number 18C. 3 cotangent square theta plus 5 cosecant theta plus 1 equals to 0 for theta in between 0 to 2 pi. Before we start answering this question, we have to take note about the square. So square here shows that this is a quadratic equation. So when we have quadratic equation, we must understand we need to reduce this to linear. Okay, number 2, you have to take note that one of the term is cotangent and one of the term is cosecant. So when we have two different term, okay, we need to take note that we're gonna simplify this to only one term. Okay, so when the terms are different, we will be using trigonometry identity to make sure that the question is in one term. The third thing that we have to take note is the range. Notice that the given range is in terms of pi. So when we are given the range in terms of pi, we're going to give our answer in terms of pi. Okay, students? Now, let's try to answer the question. First, we're going to copy the 3 here. Second, we're going to use trigonal identity on cotangent square theta. We know that cotangent square theta is cosecant square theta minus 1. Plus, okay, why I choose to use this trigonometry identity? If I use this, now the whole equation is in terms of cosecant. So my aim here is to get this in the same term, which is cosecant. Okay, students? Okay, next we're gonna simplify this to 3 cosecant square theta minus 3 plus 5 cosecant theta plus 1 equals to 0. We can still simplify this equation. We're going to rearrange from the highest power to the lowest power. So we will be getting 3 cosecant square theta plus 5 cosecant theta minus 2 equals to 0. Next, we're going to do this as quadratic equation where this is your value of A, this is the value of B, and this is the value of C. So key in into your calculator to factorize A as 3, B as 5 and C as negative 2. So once you key in, you will get the factor as 3 cosecant theta minus 1 multiply cosecant theta plus 2 equals to 0. Okay, students, now we can find the solution. Cosecant theta is 1 over 3 and cosecant theta is negative 2. Okay, now the first step is we change all to cosecant. Second step we get quadratic. Third step we factorize. Now we manage to reduce this to linear. Once you manage to reduce this to linear, you will be able to solve this as usual as we have done in our previous videos. Now let's start with cosecant theta equals to 1 over 3. Now we know that we cannot find cosecant using the calculator, but we know cosecant is 1 over sine. So we can change this to 1 over sine theta equals to 1 over 3. Therefore, sine theta equals to 3. Okay, so that's how we try to solve for cosecant theta equals to 1 over 3. Next, we're gonna check on the sign of the sine theta. Since this is positive, so theta will fall on the first and the second quadrant. Okay, so this will be your reference angle and also theta. For the second quadrant, this is theta and your reference angle will be less than 90 degree attached to x-axis to the terminal line. So this is the theta for first and second quadrant. Now we're gonna start with finding alpha, which is the reference angle. So we're gonna find sine alpha equals to 3, alpha equals to arc sine of 3. Okay, so you have to press your calculator to find arc sine of 3. So there is no solution for arc sine of 3. So therefore our conclusion here is no solution. Okay students, for cosecant theta equals to 1 over 3. Now we're going to continue with the second answer. Cosecant theta is negative 2. Again, we know we cannot find cosecant using calculator. So we're going to use 1 over sine. Since cosecant is 1 over sine, we're going to use 1 over sine theta is negative 2. Therefore, sine theta is negative 1 over 2. Okay. Next, we're going to look into the sign of the sine theta. So the sign is negative, shows that the angle falls on the third and the fourth quadrant. Sine negative, the angle will be at the tangent and the cos quadrant, which is third and the fourth quadrant. So for the third quadrant, which belongs to tangent, so this is your theta, and the angle attached to x-axis to the terminal line less than 90 degree is your reference angle. Next, for the fourth quadrant, which belongs to cos, so theta is from x-axis anti-clockwise until the terminal line, and reference angle is at the terminal line to the x-axis. So that will be our reference angle. Okay, so we will start with finding the reference angle. So sine alpha equals to 1 over 2. To find reference angle, we do not have to consider the negative sign. So alpha is arc sine of 1 over 2. Always remember, the negative sign is to decide which quadrant does the theta falls in. Okay, so arc sine of 1 over 2 will be giving us pi over 6. Okay, so how do I get this value, pi over 6? So make sure to use radian in your calculator. If you use radian, automatically you will get the answer alpha equals to pi over 6. Now we're going to find theta. So for the second quadrant, okay, so for the second quadrant, we're going to take from x-axis until the whole second quadrant, okay, the blue color here. So this whole thing is 180 degree. So we're going to take 180 degree, we need to add with pi over 6. But remember, we have to use the term pi. So 180 degree is actually pi. So we're going to plus with the reference angle pi over 6 for the angle in the third quadrant. So that would be pi plus pi over 6. Now we have another angle at the fourth quadrant. So one whole turn here is actually 360 degree. So 360 degree is 2 pi. And our angle is only up to the terminal line, which means we're going to minus with the reference angle pi over 6. Okay, so that's how we find theta. So the final answer, theta equals to pi plus pi over 6, we will be getting 7 pi over 6. And 2 pi minus pi over 6, we will be getting 11 pi over 6. Okay students, can you follow? So it's very easy when you are given the range in terms of pi. You don't have to worry. You just have to change your mode to the radian. Change the calculator mode to the radian, and it will be giving you the answer in terms of pi. Okay, so that's for example 18C.